Hello and welcome to another Mr. Marriott Maths video, and this time we're doing question 2 of the October 2021 Edexcel Decision Maths paper. And we're told that the project is modelled by the activity network shown in figure 2. And the activities are represented by the arcs, and the number in brackets on each arc gives the time in hours to complete the corresponding activity. And question A is asking us to complete diagram 1 in the answer book to show the early event times and the late event times. And I've copied diagram 1 to the right hand side of the question. So we're going to start off at the source node and we're going to give it an early event time of 0. So if this event has an early event time of 0, that means that the event at the end of activity A has an early event time of 4. At the end of B, an early event time. And we can't actually give the event time at the end of B currently, so we have other activities going into that event. And similarly for C, we've got another activity going into the event at the end of C. So now we can start from the activity at the end of A. We can update the activities at the end of this activity. And at the end of this activity, we've got both preceding activities with early event times prior to them, so we can update the early event time at this event in the middle. 4 plus 4 is equal to 8, 0 plus 6 is equal to 6, 8 is larger than 6, so this event can't possibly start before time 8. So we're going to put an 8 right here. There's now 2 events that we can add an early event time for. I'm going to do this one at the top. If we do 4 plus 2, we're going to get 6. If we do 8 plus 0, remember dummy is still essentially an activity. It's just saying that this event here, we can't draw an arrow or E going to this event because then we'd have a dependency on B for this event, and we might not necessarily need that. So 4 plus 2 is 6, 8 plus 0 is 8. We're going to get an early event time of 8. Okay. And down at the bottom, 0 plus 10 is 10. 8 plus 5 is 13, so we're going to get an early event time of 13. And now we're going to do these final 4 events. Let's do this event up at the top. 8 plus 6 is 14. 8 plus 7 is 15, and 15 is larger, so I'm going to go over that one. And now this event in the middle. 8 plus 2 is 10. 13 plus 0 is 13. 13 is larger than 10, so I'm going to go with 13. This event at the very end I can't currently do because there's one event prior to it which I haven't done. So I'm going to do the event prior to it. 13 plus 5 is 18. And then finally, the very final event, 15 plus 7 is 22. 13 plus 6 is 19, so I'm going to keep that 22 in my mind. 13 plus 7 is 20, so I'm going to keep that 22 in my mind. And 18 plus 0 is 18. So 22 is the largest early event time. So I've now completed a forward pass, and the forward pass would get 2 marks. You're going to get a method mark for having the forward pass look like the numbers are typically increasing as we go from left to right, and then an accuracy mark for getting all of the numbers correct. So now we're going to perform the backward pass, and I'm going to start at the event that we ended at whilst doing the forward pass. That's going to get 22. So now, any event preceding an activity where the activity has a late event time at the end of it can be done. So I'm going to do my backwards pass, and I'm going to get 22 subtract 7. It's being 15 for this event at the top. going to do 22 subtract 0 is 22 for this event down at the bottom. And then finally, I can do this event in the middle. 22 subtract 6 is 16. And now that I've completed the late event time for this event here, I can do this event at the bottom. Because I've got to do all 3 edges going into that event. 16 subtract 0 is 16. 22 subtract 7 is 15. And 22 subtract 5 is 17. I'm going to take the smallest time now. Because in order for this event with late event time 22 to take place, the preceding event at the start of activity L must start by time 15. If this event starts any later, we're going to disrupt this event here at the very end. And we're going to do the backward pass for other events as well. So 15 subtract 6 gives me 9 for this event at the top middle. Then last but not least for the middle events, 15 subtract 7 is 8. 16 subtract 2 is 14. And 15 subtract 5 is 10. So the smallest value is an 8 there. Continuing this, I can go to this event at the top. 8 subtract 4 is 4. 9 subtract 2 is 7. So I'm going to get a late event time of 4. And last but not least, I should get a 0 down at this late event time on the very left. But let's try it. 15 subtract 10 is 5. 8 subtract 6 is 2. 4 subtract 4 is 0, which is good news. So now I've completed the late event times. And just like the forward pass, you're going to get a method mark for doing the backwards pass with the numbers typically decreasing as we go from right to left, and an accuracy mark for getting all of these numbers correct. So now question B, you were asked to calculate, or really I should tell you the information just before B, each activity requires 1 worker and the project must be completed in the shortest possible time using as few workers as possible. And we're asked to calculate a lower bound for the number of workers needed to complete the project in the shortest possible time. And we must show our working. So we're going to calculate the total duration of activities. And to do that, we're just going to add up all of the durations of each of the activities. We're going to get 4 plus 6 is 10, plus 10 is 20. We're going to go to D, 22, E, 26, F, 31, G, 37, H, 44, I, 46, J, 53, K, 59, L, 66, and M, 71. So total duration of activities is 71. And if you proceed alphabetically through all of the activities, you make sure that you're not missing any activities by accident. And you can use a calculator for this. And we need to complete the entire project in 22 hours. So completion time is going to be 22 hours. And we've got 71 hours of tasks. So we're going to do 71 divided by 22. And that's equal to 3.22 ... So if we used 3 workers, we can't complete this project in time. Sorry about that. So that implies that we need 4 workers. So you've got a method mark for doing the division 71 divided by 22. And this method mark actually allows any number within 10 of 71. So as long as you did any number between 61 and 81 divided by 22, that's acceptable. And then an accuracy mark for the correct answer only of 4 workers. So had you done 61, 62, 63, 64, 65 or 66 divided by 22, although you would have got a method mark, you wouldn't have got the accuracy mark. And it is actually a correct solution only. So if you didn't do a 71, you wouldn't get this accuracy mark. And finally, question C, schedule the activities using grid 1 in the answer book. I've been really kind and provided grid 1. So now I'm going to try scheduling it. And I'm going to try identifying my critical path, because one worker can continuously be working on the critical path. And I can see that my critical path always has to start an event that has the same early and late event time, and has to end at an event with the same early and late event time. But that's not necessarily true in the other direction. I'm going to see whether I just have one path. And it does appear that I have just a single path. So I've got this path here, A, E, H and J. So this is my critical path. So one of my workers is going to be working just on this path. So I'm going to get an activity of duration 4, and that's going to be A. An activity of duration 4 going to time 8, and that's going to be E. An activity of duration 7 ending at time 15, and that's going to be my H. And finally, an activity of duration 7 ending at time 22, and that's going to be J. So I've done my critical path. So now I'm going to do activity B. I'm going to have a one worker starting on activity B, and that has duration 6. And I'm going to start a worker off doing activity C. That has duration 10. I can't actually utilise a fourth worker right now because the only 3 activities that begin at time 0 are A, B and C. Once A is complete, I can start E. And I can also start D. So I could choose to utilise a fourth worker for D. But actually, until activity B is done, I can't start activities G, H or I. So I could actually put this activity after activity B for worker number 2. That does fit in quite nicely. So activity D seems to fit in quite nicely after that. And then what could I do next? Well, now I've scheduled A, B, C, D, E. I could schedule activity F, but activity F actually doesn't need to finish until time 15, so worker number 3 could do activity F. There's some more pressing activities that definitely need to happen. Those activities are activity G needs to begin by time 9, and activity H needs to begin by time 8. Activity H has already been scheduled though, so I'm going to schedule G. G is the most pressing activity right now. And G is going to go on until time 14 for worker number 2. And now I can schedule activity F. And activity F I'm going to give to worker number 3. And that's going to have a duration of 5, which is going to take us up to 15. So currently we're completing all of the activities by the late event time. So I've done A, B, C, D, E, F, G, H. I'm going to schedule activity I. An activity I can be given to a worker 2 at the earliest possible time. And it's still being completed by time 16, so that's good news. I've done J, let's try K, L and M. Well, activity K can occur once activities F and I are complete. So once activities F and I are complete, I can just do activity K immediately. So I'm going to do K right after I. And K has a duration of 6, which is going to take me up to 22. I'm going to do the same thing for L. As soon as F is done, I'm going to do activity L with a duration of 7. And that's taken me up to 22 as well. So there's only one activity left, and that's activity M. So I'm going to give activity M to a 4th worker because there's no possible way I can fit it in my diagram elsewhere. So the early event time prior to M is 13. But I can't begin M at time 13. I can only begin M once C and F are complete. And F completes at time 15, so I can start M then. And it has a duration of 5. So I'm going to add my M at the bottom there. So how is this marked? Well, it's a free marker, and you get the first method mark for not drawing a Gantt chart. If you draw a Gantt chart, you do not get any marks for this question. You also need to use at most 4 workers, which has happened, and at least 9 of the activities have to have been placed. You get an accuracy mark for using exactly 4 workers, for having all 13 activities present, and you're allowed at most 2 errors. And an activity can give rise to at most 3 errors, 1 on the duration, 1 on the time interval, and 1 on the immediately preceding activity. So by errors, if a duration of a task is wrong, that's an error. If the time interval that the task takes place in isn't realistic to complete the project by time 22, that's an error. And if the immediately preceding activity of, say, J, which is G and H, aren't complete by the time J begins, that's an error. You can only have 2 errors for this accuracy mark. And then last but not least, a final accuracy mark for scheduling all 13 activities correctly. The schedule can look different to this. Activity M could, for instance, take place at time 17 and finish at time 22. Or there could be different choices made about when to schedule certain activities. So thank you for watching, and until next time, have a good day.